This is really tomorrow night's homework, but I thought that it would be useful for you guys to see it tonight, since I have a feeling there are a couple questions like these on the quiz tomorrow. So this is a bonus for anybody who's paying attention to Edmodo. I hope you all watch Edmodo every night. This is all about answering the question in, out, or on. Of course, you could just memorize it. Specifically, it's worth memorizing that for acute triangles, like these first triangles, no matter what triangle center you're dealing with, circumcenter, incenter, centroid, or orthocenter, for an acute triangle, those are always inside the triangle. So you should definitely go ahead and memorize that. In fact, when you draw your picture, if you do it right, drawing your perpendicular bisectors and your angle bisectors and your medians and your altitudes, notice all of these are examples of acute triangles, and notice that in each case they do in fact meet inside the triangle. But also notice they're not in the same spot. This is kind of low, this is higher, this is a little bit more to the right, this is much higher. So these are different places in the triangle, but they are all inside the triangle for an acute triangle. So all you really have to worry about is the obtuse triangles and the right triangles. So if you wanted to memorize it, it's easy to remember that incenter is always in, because of the word in, and whether it's obtuse triangle or right triangle, notice that incenter is always in. And maybe the fact that this is the centroid, you can hear the root word center in there, and that reminds you of being in the middle, which might remind you of being inside the triangle. Centroid is always inside. Incenter is always inside. So the only two that really can be outside the triangle are circumcenter and orthocenter. And that's both in the case of an obtuse triangle, circumcenter will be outside, and orthocenter will be outside. And in both of those cases, for a right triangle, it's right on the triangle. Okay, so it wouldn't be that hard to memorize if you wanted to just memorize it. But also, you could draw a quick little sketch, and you could just see quickly whether it's inside, outside, or on the triangle. To be able to do a quick little sketch, you have to know these key words. You have to know that circumcenter is perpendicular bisectors, like these. Incenter is angle bisectors. See the angles being split? Centroid are medians from a vertex to a midpoint. And orthocenter is made of altitudes from a vertex to a perpendicular every time. If you know the definitions of those words, you can do a quick sketch. Okay, so for example, say if I forgot whether or not a circumcenter was inside, outside, or on the triangle. Of course, for an acute triangle, we will just go ahead and memorize it. Acute triangle, it's always going to be inside. Okay, I mean for your homework you have to draw it, but I'll come back to that. So let's just deal with the obtuse triangle and the right triangle. Okay, you had to remember that a circumcenter is the intersection of perpendicular bisectors. Okay, so they have to form a 90-degree angle and cut the side in half. So I'm going to try to do this like you guys might, and just do a really rough sketch just with my pen instead of using my lines, which are neater. Okay, so first of all, looking at this side over here, the middle seems to be about here, and here I go trying to make a perpendicular line as best I can. Okay, that was a fail. Let me try a little bit better than that. Okay, so here goes a perpendicular line. It's a little bit better. Okay, I'll put it out this side. So look, I'm just shooting for a rough sketch here. So there's a perpendicular bisector. Now let's do the same thing on this side. Okay, here's maybe the middle of this side, and about here would be perpendicular. Okay, you really only have to do two of them because they all should meet at the same spot. But boom, right there is where my perpendicular bisectors are meeting, clearly outside, okay, the triangle. If I do the same thing for the right triangle, it looks like this. Here's the midpoint, okay, and here's my perpendicular line. I'm trying to do perpendicular bisectors, remember? So there's one of them, and then here's the midpoint, okay, and so if I try to do my perpendicular line, okay, so this is off a little bit, but you can see how close that is to being on the edge. For the right triangle, if it's outside for obtuse, it should be on the triangle for a right triangle. So you see how close this is. So you can go ahead and imagine that if we had done it perfectly, it would have been on the hypotenuse, like right there. Okay? And why not? Let's go ahead and follow through. We know that it's always going to be inside for acute, but let's go ahead and do the rough sketch. See how fast you can do this. You would just go like this, okay? That's about perpendicular bisector. I'll do this one right here. Okay, this is the midpoint just about. There's my perpendicular bisector. You can see that meets on the inside. Okay, incenter is the intersection of angle bisectors. Angle bisectors cut the angle in half. So we know it should be on the inside for an acute triangle. I'll just go ahead and draw it real fast. I'm looking to split the angles in half. Okay, I'm splitting that in half. Now I'm trying to split this one in half as best I can. Split, 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 split. Now I'm splitting this one in half. Okay, kabam. Okay, so that was definitely inside. Okay, now let's skip to the obtuse one. Again, these are supposed to be angle bisectors, so I'm splitting angles in half. That's my focus. So if I try that here, okay, I just split this angle down the middle. Now I'm trying to split this angle down the middle as best I can. Okay, zip, 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 zip. Okay, it's looking like it's about there. I'm going to split this one down the middle as best I can. Okay, so it looks like it's going to be about there. You should really use a ruler. Okay, in fact, in your homework tomorrow, notice it says you must use a ruler. See how it says you must show markings? That's what I'm doing when I put these marks on here like this. Okay, so you make sure you show all your markings like you're supposed to. That's why I'm putting these marks. Okay, so that's definitely inside as well. So as soon as I see that it's inside for obtuse, I know it's going to be inside for a right triangle. But just to follow through, splitting the angle, splitting the angle, splitting the angle, inside. Centroid is the intersection of medians. Okay, medians go from a vertex to a midpoint. So here's a vertex, here's a midpoint, zip zap. Okay, so there's a median, vertex to a midpoint. Let's do it again. Here's a midpoint, so vertex to a midpoint. Here's a midpoint, vertex to a midpoint. Okay, we know acute triangle is always in, so I just did that for fun. Let's skip to the obtuse triangle. Okay, vertex to a midpoint. These are medians. So vertex to a midpoint. Okay, let's do it again. There's a midpoint. So vertex to a midpoint. Here's a midpoint. Vertex to a midpoint. Okay? This would look better with a ruler, but this is definitely also in. If the obtuse triangle is inside, you know the right triangle is going to be inside as well. Okay, let's see, what about orthocenter? Remember, orthocenter is the intersection of altitudes. So when I do my intersection of altitudes, altitude goes from a vertex to a perpendicular. So that's going to be like this. Start at a vertex, drop down perpendicular. So that's an altitude. Okay, this one's going to be a little tougher. I got to keep an eye on my perpendicular as best I can. Okay, vertex to a perpendicular. That looks pretty close to me. Okay. Alright. These are my three altitudes. So that's definitely going to be inside. Now let's skip to the obtuse one. Okay. Now I have to be careful. This one would be pretty easy. Vertex to a perpendicular. Okay. That one's going to be like that. Now the other one is going to take a little bit of thought. If I have my vertex and I want to go perpendicular, but if I stay inside the triangle, there's no way for it to be perpendicular. So what I have to do is I have to extend this side with a dotted line or something. Alright, so when I go vertex to perpendicular, I'm going to go perpendicular out here. Okay, so vertex to perpendicular, there's my altitude. Now, can you see where these lines are trying to meet? They're probably going off the paper actually, so that's going to be a little bit tough. Okay, because these, if I extended these lines further, okay, can you see that they will eventually meet off paper down here at the bottom somewhere? Okay, so that's definitely outside of the triangle, and I didn't quite leave enough room for it. I probably should put this one at the top. Should probably switch those. Anyway, so that's how I can see that this one's inside, but this one is outside. Just for fun, if I went to do the other one, the other side, the other altitude, it would look like this. Again, I'm trying to go from a vertex to a perpendicular, but that's going to be outside of the triangle. So I need to extend this side a little bit with maybe some dotted lines. Okay, so when I go vertex to a perpendicular, it's going to be like that. Alright, there's my altitude from here. And again, if I extend this further, eventually all three of them will meet off camera down here someplace. Alright, so this last one. Let's see what happens for the right triangle. Now you can bet that when the obtuse triangle gives you an orthocenter that's outside, for the right triangle it will be on the triangle. But will it be on the hypotenuse or will it be on the little corner here? Like where on the right triangle will it be? We can find out. Altitude goes from a vertex to a perpendicular. So guess what? This red line right here is an altitude because it goes from the vertex and it's perpendicular. So that's one altitude. Okay, let's do one from this side over here. Vertex, perpendicular. Alright, because it's a right triangle, this line right here happens to be another altitude. Vertex, perpendicular. These two red lines are both altitudes. So you can see they both meet right here. That is the orthocenter. Now, if I went from vertex, of course it's going to start here because that's a vertex, and I went perpendicular, that would be my third one. But again, they all meet right here. So that is definitely on the triangle. So this is how you do your in, out, on analysis. You just draw a picture of an acute triangle or a right triangle or an obtuse triangle, and then you use the definition of each shape. If it's orthocenter, you draw some altitudes and see what happens. If it's centroid, you draw some medians, vertex to a midpoint. If it's incenter, you draw some angle bisectors. Okay, split these angles in half. And if it's circumcenter, you draw yourself some perpendicular bisectors. Perpendicular bisectors. And just see where they meet. Inside, outside, or on the triangle. Okay, so that's a little review of how you could find out if it's inside, outside, or on the triangle, aside from just memorizing it. Alright, and please note, like these shapes I just did, you don't need some big old triangle to do what I just did. See these tiny little triangles right here? You can make a little sketch and figure out really quickly if it's inside, outside, or on the triangle. Okay, let's see which one I'm doing. Well, that's centroid, but for example, orthocenter, no, circumcenter, perpendicular bisectors. You could just quickly go, okay, that's my midpoint, there's my perpendicular bisector. Okay, there's my midpoint, there's my perpendicular bisector. Okay, there's my midpoint, there's my perpendicular bisector. Outside. Okay, you can just do it real quick even on these tiny little graphs.